What if I told you that one tiny mistake in the first fraction of a second after the Big Bang, and none of this would exist? No stars, no planets, no galaxies, no time, no you. Not destroyed by some cosmic explosion or alien force, but erased before anything could even begin. Scientists have discovered that the universe came terrifyingly close to destroying itself in its very first moments. And here's the truly disturbing part. It almost happened without leaving any trace that it ever tried to exist at all. Tonight, I'm going to show you the universe's closest brush with total annihilation, and why some of the world's leading physicists believe it could still happen again. Stay with me, because the ending of this story hasn't been written yet. Let's go back 13.8 billion years to the moment everything began. You've probably heard about the Big Bang, but I need you to forget the image of fireworks exploding in space. That's not what happened. The Big Bang wasn't an explosion in space, it was an explosion of space itself. Every point in the universe was the center of the explosion. Space, time, matter, and energy all erupted into existence simultaneously from a singularity smaller than an atom. In the first fraction of a second, temperatures exceeded 1 trillion degrees Celsius. The four fundamental forces we know today, gravity, electromagnetism, and the strong and weak nuclear forces, were merged into a single unified force. Reality itself was completely unstable. The laws of physics as we understand them today shouldn't have survived this phase at all, and yet somehow they did. But why? What saved the universe from immediate self-destruction? The answer is that the universe balanced on a razor's edge, and I mean that literally. The universe is governed by what physicists call fundamental constants. These are numbers that determine how reality works: the strength of gravity, the speed of light, the mass of electrons. These numbers are so precise, so impossibly delicate, that changing them even slightly would destroy everything. Let me give you just one example that will blow your mind. There's a value called the cosmological constant. It controls the rate at which the universe expands. Now, if this number were just slightly stronger, the universe would expand so fast that matter could never clump together to form stars or galaxies. Everything would be spread too thin. But if it were slightly weaker, gravity would overpower expansion and collapse everything into a massive black hole within moments of the Big Bang. So what's the margin of error here? How close did this number need to be to the right value? 1 part in 10 to the power of 120. Let me put that in perspective for you. That's like trying to hit a single atom on the far side of the observable universe with an arrow while blindfolded. And you have to make that shot on your first try. No practice rounds, no second chances. The universe got it exactly right. Too perfect, almost suspiciously perfect.
But it gets even more terrifying when we look at what happened during the universe's infancy. In its earliest moments, the universe went through a phase called cosmic inflation. For a brief instant, space expanded faster than the speed of light itself. Now, I know what you're thinking. Doesn't Einstein's theory say nothing can travel faster than light? You're right, but space itself isn't bound by that rule. Only objects moving through space are. During inflation, the universe existed in what's called a false vacuum state. Imagine a ball balanced perfectly on top of a hill. It's stable for the moment, but it's not in the lowest energy state possible. The ball wants to roll down. It's precarious. One tiny push, one quantum fluctuation, and it tumbles down the hill, releasing all that potential energy. Now apply that to the entire universe. If cosmic inflation had lasted even a fraction of a second longer than it did, or if it had ended differently, the universe would have collapsed into that lower energy state instantly. No second chance, no restart button, just complete annihilation before anything could form. And here's what keeps physicists awake at night. This wasn't just unlikely. According to our best models, this outcome was almost inevitable. The universe should have failed. The fact that we're here talking about this is, statistically speaking, miraculous. Now we need to talk about one of the most terrifying concepts in all of physics. It's called vacuum decay, and it represents the ultimate cosmic threat. According to quantum field theory, the vacuum of space isn't truly empty. It's filled with quantum fields that have a certain energy level. We currently exist in what might be a false vacuum, a metastable state that appears stable but isn't the lowest possible energy configuration. If that's true, then at any random moment, anywhere in the universe, a bubble of true vacuum could spontaneously form. Maybe from a high-energy particle collision, maybe from a quantum fluctuation. We don't know what would trigger it, but once that bubble forms, it would expand outward at the speed of light, and nothing could stop it. Inside the bubble, the laws of physics would be completely different. Atoms as we know them couldn't exist. The fundamental forces would have different strengths. Everything would be rewritten. There would be no warning, no alarm bells, no time to prepare. You wouldn't feel pain because your neurons wouldn't have time to fire. You wouldn't see it coming because light from the edge of the bubble would arrive at the exact same moment as the bubble itself. One instant you exist, the next instant you don't. Not just you, but every atom, every star, every galaxy. The entire observable universe could be erased in the time it takes you to blink, and we would never know it happened. And here's the part that should absolutely terrify you. We have no way of knowing if we're in a false vacuum or not. We can't measure it. We can't test for it. It might be happening right now, somewhere billions of light years away, racing toward us at the speed of light. The bubble of annihilation could be halfway here, and we'd have no idea. Let's step back for a moment and ask a bigger question. Physicists have tried to calculate the probability of a universe like ours existing with all these finely tuned constants. They've run the numbers again and again, and the answer they keep getting is essentially 0. The odds are so astronomically small that it shouldn't have happened. Stephen Hawking once said the universe appears to be fine-tuned for life. But that raises an enormous question. Fine-tuned by what? Some scientists point to the multiverse theory. Maybe there are countless universes with different physical constants, and we just happen to be in one of the rare ones that allows life to exist. We won the cosmic lottery. Others suggest there are deeper physical laws we haven't discovered yet, laws that make our universe's properties inevitable rather than accidental. But here's the truly haunting thought. If the universe had failed even once during those first moments, if any of those constants had been slightly off, there would be no observers to notice, no scientists to calculate the odds, no civilizations to wonder why. All the failed universes are invisible to us by definition. We only see the one that succeeded, which creates a massive observational bias in our understanding of cosmic probability. So let me ask you something that might change how you think about existence itself. What if the universe didn't survive because it was truly stable? What if it survived because it was just barely stable enough for now? Consider this. Dark energy is causing the expansion of the universe to accelerate. Particles decay over time. Entropy constantly increases. The universe is changing, and not all changes lead to greater stability. Some physicists believe that the universe is slowly drifting toward instability, that vacuum decay isn't just possible but inevitable given enough time, that the end of everything may already be encoded into the fundamental structure of reality itself, just waiting for the right moment to activate. If they're right, the universe won't end in a spectacular explosion. It won't fade away slowly. It will simply switch off, like someone flipping a light switch, and everything will cease to exist in an instant. So here's the question I want to leave you with. Was the universe designed with these precise constants? Are we incredibly lucky to exist in the one successful universe out of countless failed attempts? Or are we living inside a cosmic accident that beat impossible odds and almost never happened? Because if the universe almost destroyed itself once in those first moments, if it balanced on that razor's edge and somehow survived, who's to say it won't try again? And if it does, we won't see it coming. The most dangerous moment in the universe's history may not be in the past. It might be approaching us right now at the speed of light. Sweet dreams. If this video made you question the nature of reality, hit that like button. If you want to explore more cosmic mysteries that will keep you awake at night, subscribe and turn on notifications. And I want to know what you think. Drop a comment below. Do you believe the universe is fine-tuned by design, or are we just the winners of an impossible cosmic lottery? Let me know, because this conversation is just getting started.